Here's the thing, guys. Ne? There's no secret to anything, to be honest. Like the secret is just to put efforts, practice more and more and more and more. What we can do is we can just help to unlock some of the things that we may find challenging here and there. But there's no other way around. I can make as many videos as I can. Still, you have to put that effort to sit down and study. I was talking to one of my friends and I'm like, I can't think of any AI tool that can work to inspire or motivate someone to have that willingness to want to learn themselves, or to want to study themselves. Because mostly it gets to a point where we are doing it because the parents are paying and we have to go to school, right? On today's question, before I go further with this parental things, whatever, on today's question, we'll look at question 9.3. It reads, a solution of sodium carbonate was prepared by dissolving 5 grams of the powder in 100 centimeter cube of water. So this is what's happening. Um, I think I can make an example with this. I was having tea right now. So think of it like this. The situation here is sodium carbonate was prepared by dissolving 5 grams of the powder in 100 centimeters cubed solution of water. So it's like they took the powder and it on the water to prepare the solution. So now that's why on the balance equation there, it's in aqueous solution, the sodium carbonate. Also, it is advisable to practice and study your compounds, like because either way, if you are doing physics and you have to write paper 2 and paper 1, so now meaning I'm communicating to students from grade 10, grade 11, and grade 12, as well as far as university students in that manner. If you don't make the periodic table your friend, it's hard to achieve any good marks. Like, let me put this. So we have to make the periodic table our friend because most of the information is extracted from the periodic table itself. Now, the question, the way I'm stating there, that they took the powder of 5 grams and mixed it with water to prepare the sodium carbonate. The solution reacted with barium chloride solution. So now it reacted with barium chloride solution according to the following balanced chemical equation. There we have our balanced chemical equation. So we can see the sodium carbonate, and then we can see it reacting with the barium chloride, and then it forms barium carbonate, which is now in solid form. You can see that there's S next to it. And then it also formed sodium chloride, which is just in aqueous solution, part of the solutions inside there. And then 9.3.1, we are required to calculate the mass of barium carbonate that should form in this reaction. We should calculate the mass of the solid formed barium carbonate on the other side of the equation, right? Let's break it down so it can make sense. This is what we have here. As you can see, I already prepared our balanced equation, right? So this is what we have. What we are given here, we know that the mass of sodium carbonate, we know that the mass of sodium carbonate, it was 5 grams. We are required to calculate the mass of barium carbonate, which is this. We are required to calculate the mass of this. So we are required to calculate the mass of this. However, we know that the formula to calculate mass, from this formula, we first have this formula that says number of moles is equals to the mass of a compound divided by its molar mass. So we have this formula that says the number of moles is equals to the mass of a compound divided by this molar mass. Playing around with your mathematics, you can see that calculating the mass of this, we're going to need the number of moles multiplied by the molar mass. If you want to look at a bigger picture from here, you can see here, I just cross multiplied. Guys, physics and chemistry is like calculations, just like mathematics. What's happening here Let me take you back to paper one when we used to have this situation when we're talking about speed, distance, and time. We said if you want to calculate speed, you just load speed in that to summarize. So we said speed is going to be distance over time in this scenario, right? If you want to calculate the time, you just lose the t there, and then whatever is yield, you will get that t is equals to distance over the speed. And also, if you want to calculate the distance, you just lose the distance there, and then whatever you get, you're going to get speed multiplied by time like that. If you remember that summary like that, you can relate the very same thing to this formula, N is equals to MR, where I'll put N here, I'll put MR here, big letter, big MR, and then I'll put small letter M here. So from here again, you can see that if you want to calculate N, if you cover N, N is equals to M over R. If you want to calculate the small letter M, now the small letter M will be N times R. Meaning if you want to calculate MR, MR would then be, MR would be small letter M over small letter N like this. But however, you can calculate MR directly from each compound from here if you have the compound. So you won't necessarily have to worry about this. I just wanted you to get the mathematics behind. Chemistry and physics is just calculations as they are in mathematics, you don't have to think as hard. So now, if we can get the number of moles of sodium carbonate, we can relate that by comparing the coefficient of each and every compound, because the number of moles is in the same system, and the number of moles is just the unit measure of each compound like that. So here we can get the number of moles, of Na2CO3. We can get that by saying is M, small letter M, all over the molar mass, you see. But now, we know the mass is 5 kg. But then what is the molar mass, MR? What is the molar mass of sodium carbonate? Now, to calculate the molar mass of sodium carbonate, you simply just say, so this is how I break it down. From Na2CO3, I have two sodiums. Plus one carbon, plus one carbon, plus three oxygens, like that. And then from here, to get the molar mass, I just get the values of the atomic mass from the periodic table. And to get that, it's just going to be 2 is 2. Sodium is going to be 22 point. Let me just be accurate. Sodium is 22.990 plus carbon. Carbon is 12.011 plus nitrogen. Nitrogen element number 7, but the atomic mass is going to be 3 into 15.999. The closest value. So the molar mass will then be the number of moles will then be, if I divide 5 by 106, the number of moles will be 0.047. That is 0.04717, blah, blah, blah. I'm just taking it like this because I want to make it shorter. It's going to be 0.047 moles like that. But look, I still have to calculate the mass of barium carbonate. That's the whole goal of our question. So now I just want to get the number of moles of barium carbonate as well in relation to sodium carbonate, because once I get this number of moles, I can compare on the balance equation to can tell based on the ratio of the compounds, because we can see here 1:1, 1:1, but then here is 1:2. So Because barium carbonate and sodium carbonate share a 1:1 ratio on the coefficient of the compounds, it means that I can assume that the number of moles of barium carbonate is going to be 0.047 as well. But look at this. If I needed to calculate the number of moles of sodium chloride, it would have been, now I would compare 1:2. So it would have been 0.47 times 2, because here it formed two products, but otherwise here is 1:1. So it's safe to say the number of moles for barium carbonate is also 0.047, like that, multiplied by the molar mass of barium carbonate. So I'm closer to finding the mass. I'm closer to calculating. I'm closer to answering the question that they want. But now I need to calculate the molar mass as well. By knowing the compound as it is, I can calculate the molar mass quickly, the way I did here with the molar mass of sodium carbonate. Because then I will say molar mass for sodium for barium carbonate is going to be Ba plus carbon plus 3 oxygens. Therefore, let me just look on the periodic table. Barium, element number 56. Barium, the atomic mass is 137.33. 137.33, and carbon is 12.011, and oxygen we have 3 into 15.999. And when we multiply and add this together, we get 197.33. So we get 197.33. Therefore, the mass, to get the mass, I will then say the number of moles of carbon, the number of moles of barium carbonate, which I found by comparing the number of moles of sodium carbonate, multiplied by the atomic mass of barium carbonate, which I now calculated, and I found it to be 197.33. This should give me the mass of barium carbonate. So the mass of barium carbonate is going to be this times that. So that means the barium carbonate that was formed, it was 9.27 grams. So the mass of the barium carbonate that was formed from the reaction, it was 9.27 grams. That is how we answer 9.3.1. The question, right? We were required to calculate the mass of the barium carbonate that was formed from this reaction. In the question, we are given the mass of sodium carbonate. And now we have to calculate the mass of barium carbonate. Now, to calculate the mass of the barium carbonate, we know that from the formula, number of moles is equals to mass over molar mass. We could get the mass by just multiplying the number of moles of barium carbonate plus its molar mass. And to get the molar mass of barium carbonate is easy because we calculate it like this. We always, from this value, we always get it on the periodic table. So MR on the formula is nothing to be worried about because you're always going to get it on the periodic table. And then now, because now you realize that it's going to be hard for you to calculate the number of moles because you don't have any other information that is relevant for you in terms of the barium carbonate. And then you remember like, oh, I'm given the mass of sodium carbonate, which is that. Now, from the mass of sodium carbonate, I can get the number of moles of sodium carbonate by just using the very simple formula of dividing the mass with the molar mass. Now, again, from the periodic table, you can calculate the molar mass of sodium carbonate, and then you calculated it and found it to be that. And then 5 divided by the molar mass, it gives us 0.047 moles of sodium carbonate. But because the number of moles is just the measuring unit, we can compare the number of moles of each and every compound by just, as long as the equation is balanced, we can compare using the ratio of the coefficient of each and every compound. By the coefficient, we talk about the number that is attached at the back of each and every compound. And then from now, we realize that if the number of moles of this is 1, also this, the number of moles will be 1. If the number of moles of this will be 2, this one would be 2 because of the coefficient of 2. Now, we were happy to find that the number of moles of sodium carbonate was 0.047. And then we compared the number of moles of sodium carbonate to barium carbonate, and we find that the ratio is 1:1, meaning also the number of moles of barium carbonate could then be 0.047, like that. And then we took the number of moles of barium carbonate, we multiplied it with the atomic mass, with the molar mass, which we calculated like this from here, and then we got the mass to be 9.27 grams of barium carbonate, meaning that solid that was formed from the solution, from the entire reaction for barium carbonate, it was the mass of 9.27 grams. So it goes on and says, it was found that only 8.3 grams precipitate was formed. Remember, on 9.3.1, we calculated the theoretical grams that should be formed on the reaction, on the balanced equation. Now, in real life, or after the actual experiment was done, they discovered that it's only 8.3 of the amounts that they have as compared to the original calculated. So we calculated 9.27. They found actually 8.3 in reality. And then the calculations, they want us to calculate the percentage yield. And then it's easy. To calculate the percentage yield, you just take the actual one that they found, you divide by the theoretical one that you calculated, and then you multiply by 100. So this is how we do it in practical. Over theoretical yield multiplied by 100%. Multiplied by 100%. So this means I would then say 8.3 grams divided by 9.27 grams times 100%. This is how I calculate the percentage yield. So this is for 9.3.2. So the percentage yield is going to be this value here. It will be 8.3 divided by 9.27 that times 100. Therefore, I get 89.53%. So this is the percentage yield, 89.53%. So this is how you solve this one, guys. There's nothing hard there. You just go like this and you got all the marks. So if you've watched till this far, thank you for watching. Please remember to subscribe and follow us in all social media platforms. Mainly, you must also follow us on TikTok because there are random times where we go live. And what else? Join us next time as we do more videos like this. I'm Mr. Maimane. This is Simplified RSA. We are the guys who makes it look easy.